Stuff with Fabricius, Charlotte Vaughan and Tyler Kendall. They'll be talking about plotting speakers' vowel systems in real-time interaction, a first approach.
Okay, thanks very much, Carmen. I'll just start by saying that when we talk about real-time here, it's put in inverted commas. We're not talking about real-time as sociolinguists usually talk about real-time. Here we're interested in looking at interactional real-time, okay? So something closer to what other people understand by real-time. And Charlotte and I will be doing the presentation, but of course Tyler's here as well, so we can all fend questions at the end. Okay, so here's a bit on the structure of the talk. Charlotte will come in at the method section, and I'll take care of the rest. Okay, so we're working on the background that will be familiar, I hope, to most of you, to do with the tradition of representing vocalic data by means of a two-dimensional vowel plot, representing vowel production in this two-dimensional space. Now, working as sociolinguists, we've gotten interested in various ways in looking at the vowel space and trying to apply metrics to it, for instance. And developing the basic F1, F2 plot, which now has been around for around 60 to 70 years. Tyler Kendall, together with Fridland, has done some work on representing vowel spaces in 3 dimensions. Joos Fruehwald, who's also here, has done work on real-time, and by that I mean sociolinguistic real-time, transitions through Philadelphia English. Yeah? And here we're going to be talking about interactional real-time. By that I mean through the course of an interview. Okay, what we have here as data is one sociolinguistic interview lasting approximately 40 minutes. It was recorded originally in a sound-treated room. And it was an interview that was conducted by myself with my Australian background. Okay? And my interviewee was a British female undergraduate at a collegiate university. She was born in 1990. She was 18 at the time of the recording. She was herself from a public school background in the south of England. Her parental occupations were upper middle class. So I guess you could say she was a kind of a really good candidate for what you might want to call the generational successor to RP. Okay? Now our research question then. Here we've got an example of a cross-varietal interaction. We've got an interviewer with an Australian background who at this point, myself, had done quite a lot of these interviews for quite a long time, back in the 1990s and in 2008. And this is this interviewee with an upper middle class English background. Now does this distinction, the fact that we're speaking 2 different varieties of English, have any linguistic consequences? And in a sense we want it not to have linguistic consequences, because if I'm interviewing her with the purpose of trying to get hold of the way that she speaks as an upper middle class English speaker, then I want to know that in a sense I'm not, if you like, polluting her vowel data. So that's the question that arises. Does this interaction have any linguistic consequences? All right, so here's a vowel plot using the Erb scale, this one. This is from Hawkins and Midgley's publication from 2005. These are the 3 vowels we're going to be looking at. This is the area of the trap vowel, okay? And here we have the start vowel, ringed in red, and here we have the nurse vowel, okay? Sitting there more or less in the center of the vowel space. There's nurse. And the thing to notice about this also, as a representation of RP, is that we have a split between the strut vowel, which is not circled, but it's right here. But there's a distinction between strut and start, or cut and cart, okay? So the distinction between those 2 vowels is not just quantity or length, it's quality. And here we have a plot. This is on a different scale. This is a Bark scale, but this was what I was able to get hold of, just to give you a comparison as a representation of Australian English. And here we have the trap vowel circled. Here we have the start vowel circled. And here we have nurse in the center of the vowel space. Okay? And you'll notice also that cut and cart overlap. What's characteristic of Australian English is that those 2 vowels have a length distinction only. Okay? The placement of it can be different depending on what type of Australian English you speak. So a quite broad Australian accent, it would be something like cat cat. Okay? Cat cat. But for mine, it's clearly an overlap, cut, cart, but it's further back than it would be for broad Australian speakers. Alrighty. I've just got some sound files here where you can hear some examples of these particular tokens that we're interested in. And this was because I noticed that things were going on with her nurse vowel. You saw in the RP plot, if we remember back to that nurse in that Hawkins and Midgley paper was placed pretty much in the centre of the vowel space. But try and listen to some of her productions up against mine productions and see if we can hear some differences. And I'll get Charlotte to come and help me if I muck up the sound playing, okay? This is a Mac, I'm not used to Macs.
Right.
Okay, so try the German examples.
Okay. German, 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 and German. Yeah.
Yeah, so both of us together. Just agreeing on this word. Okay, we can go on. Yeah. And then I have some more examples here. Just play them quickly through.
Excited, dispersed, nervous, nervous, perfect, perfect.
So there's a bit of variation in the height of these things that she's
With her.
Yeah, that she's doing. Okay? Yeah. So what's going on there? Thanks, Charlotte. Okay. Then we have the trap vowel again, which is slightly differently placed for her compared to me. So here's matter.
Matter.
And her matter, I think.
Matter.
Yeah, I'll play it again.
Matter.
Matter, yeah. Her again.
Matter.
And me again.
Mattering.
Mattering, yeah. Okay. Okay, so our research question to formulate that then. Can we hear, for example, whether there's accommodation or a lack of accommodation across these varieties of English across the interview? And can we plot it? Can we see it in interactional real time? What does this animation process help us to see? And then I hand over to Charlotte.
Okay, so as Anne mentioned, so what we're interested in is trying to actually look at this interview and plot it in real time, as we're calling it. And to do this, we need a whole lot of tokens. So I'm going to go fairly quickly through this. This isn't the main point of the talk, but I wanted to let you know what we used. And Tyler can answer questions about this particular portion at the end. So the interview was transcribed in the chat format using CLAN, the CLAN tools. It was then converted to a Pratt text grid, also using the CLAN tools. And we used the Fav forced aligner to do the aligning and the extraction so the phone level segmentation and then the actual format measurements for the vowels with a couple caveats here. So we realize that Fav is built around US English, so it isn't ideal for the varieties that we're looking at, but what it can do really well is process multiple speakers at one time. So that was a really nice use of this for us. And so also just to note, we have about 3,500 tokens. They're not all hand corrected, so we're really just trying to explore the possibilities here. So if we've kind of hand corrected things in particular portions that we're looking at in detail, but besides that, it's just what the forced aligner gave us. So to go from the data to then trying to figure out how exactly we're going to display this information, there are a whole lot of options and a couple main criteria that we were interested in to help us kind of narrow down which options we were going to use. So many of you will be familiar with some of these. Processing is popular. Flare, a lot of them use JavaScript and ActionScript for the visualization capabilities. But what we really wanted were these two criteria here. So first of all, aligning the visual information with the audio would be really nice. So we want to be able to listen to the interview and actually see the vowels as they're happening. And we want something that's relatively automated, customizable, reproducible, and interactive. And so what we've come up with for today is sort of a first pass at this. And we have two different tools that I'll talk about more in a minute, and one of them is pretty strong in one direction and not so much in the other direction, and vice versa for the other one. So what I'll be talking about first is the Google motion chart, which we've implemented with Google Viz, which is a package in R. And this, you'll see a picture over here. This was sort of popularized in 2006 to the masses by Hans Rosling in a TED talk. He does a lot of visualization with population data. So a motion chart is basically just a bubble chart that is animated, which many of you are familiar with, I'm sure. And it has been used in linguistic work, as Anne mentioned, by Joe Fruehwald, who's here, and also Martin Hilpert has done some nice work and has actually some nice tutorials on using this as well. And then also we are using the vowels package in R, which Tyler and Eric Thomas wrote, and have basically generated a series of time-specific plots throughout the interview and then just sort of stitched them together. So the first one, Google Motion Charts doesn't have a straightforward way to present the audio with the visual information, which is a major drawback, but it has a lot of other neat features which are sort of helpful. And our second version of this isn't quite as interactive as we would like, but it does satisfy having the audio and the visual together. So the Google Viz package in R is very useful, very nice to use. That's what we use basically to just take an R data frame directly from the data. It then outputs a flash that you can use in your browser and customize with a little bit of JavaScript. But as anyone doing visualization knows, you have a whole lot of decisions to make about how you're going to divide up the data, and that has consequences for what you'll actually get to analyze. So first of all, I'm going to display two ways we've gone about doing this today. One is basically just sort of minute-by-minute averages over the course of the interview for each speaker. And as you'll see, that's rather noisy. They just sort of jump around. But then we've also done a cumulative average, which is a little bit smoother. So I'll switch to those real quick. OK, so this is just rendered in Firefox. This is the output of Google Viz. And I have the interviewee and the interviewer side by side. So basically this, when I press play here, you'll see it's jumping around a lot. In this particular case, the size of the bubble corresponds to the n. So how many tokens are being used in each average here. We have each vowel represented by a different color, and you can turn on and off these trails. I kind of slowed down there, which are tracking nurse and start. And then again, we can see now this is Anne talking. So what you can get out, there are a lot of nice things that this can show, and we can look at the beginning versus the end. We can highlight different vowels. And now, okay. And then, so another more smoothed way that we've gone about doing this is just a cumulative average. So every new piece of data gets averaged into the previous vowel category for that speaker. So then just as a test case, you can select any of these vowels, but we'll look at the nurse, which is what Anne has talked about. So you can see some of the little like high back vowels are jumping around a lot, but you'll also notice that the dot is really small, which means that there's a very small n there. So up until the very end, the things are getting smaller because it's trying to revert back to the beginning, I think, is what's going on. But you'll notice that the n's get bigger throughout. Okay, and then quickly, I will go through what we've done with the animated vowels plot. So this is using the vowels package in R, then basically taking snapshots in time, as I explained, and then putting them in a flipbook-like fashion. We just did this in a very sort of quick and dirty way using Apple iMovie. You could do this ideally nicely in Flash or something like that. So you'll see, oh, it's very hard to see. Maybe on that screen it's a little bit easier. But so here what you'll see is that the vowel plot, vowels appear in half-second increments, which will be tracked up across the top here. And then they'll persist for 2 seconds before they disappear. In the backgrounds, if you can see, there are ellipses, just as in the vowels package, that represent 2 standard deviations from the mean per speaker, and then that vowel the category name is plotted in the center of each, and then we're just looking at a subset of vowels here. But this is aligned to the audio, so we can listen to that here.
And you went for an interview there? Yes. Oh gosh, I remember that. Tell me about it. It's funny because we've been speaking about them now and again since we arrived here, and of course the people who did gap years, they were being interviewed in 2006, so really a long time ago. But mine is still very fresh in my mind. It was beautiful weather, very.
Okay, I'll let you hear a little more of her story later, but we had to chop it up into chunks so that there wasn't identifying information coming, but you'll get to hear a little more of her story. So she tells me all about her college interview. But let's have a look, quick flick back to the research question. What sort of things do we see then from these visual methods? What do these animations enable us to see? So we're going to look at trap and start and nurse across the two speakers, the interviewer and the interviewee. And the alignment, of course, of the audio and the video can mean that other things, depending on what you ask the animation to show you, it can bring out other possibly interesting analytical points. And I think that's one of the advantages of this visualization technique, that it enables a lot of exploratory thinking and looking and listening. But a lot of these questions will have to be answered in future work. We can't necessarily deal with them now. I'll just get to the the next extract I wanted to play. And is that just click here?
Just in the middle of the plot, should work.
Where am I? Is the mouse? I can't see the mouse. Okay, there it is.
And then I had a written test, which was quite funny. It was all about a man who made a machine, and it worked perfectly. It looked just like a human being, but then it started asking for a soul and things like that. And when I did this, my parents, my friends, they said, was this in English? And I said, yes, I did actually understand it. And we had to write a sort of a few comprehension questions and then a summary of the text. And that was fine. It was a bit odd, but fine. And then I had my subject interview, which was the scarier of the two by a long way, because I've been given a text to prepare and asking questions on it, and some things you can see the interviewer's faces sort of nodding and opening up, and other times they just look at you and it was so clear they were thinking, what is she saying? But even then it was strange. I just had no idea whether I'd got in. You can't possibly tell. And waiting was just the most impossible thing. It was awful. I remember when it got to the start of January, I was expecting the letter on January the 3rd, and I just couldn't sleep. I was having an hour a night or so.
Yeah. So she talked plenty. Yeah. And lots of tokens of vowels there. There we go. Okay. All right, some observations then. Well, it's clear when you listen to the interview, there's plenty of empathy going on from the interviewee, between the interviewer and who's saying, all sorts of things, empathetic things. But there's no clear signs of accommodation, at least in these three low vowels. My nurse vowel stays pretty much where it was. I think from the motion chart that we were looking at with Charlotte, it did look a little bit like mine kind of leapt over all over the place, but it was single tokens. It was not a systematic thing, but you could then go in and investigate that more quantitatively and say, can we do a metric on this? To what extent is accommodation actually happening? Okay, so I guess our preliminary conclusion is that the linguistic consequences are minimal here. Nurse and start for the interviewee are very much overlapped, and they're in the area around trap, low area, and they don't look, in fact, like the RP model that we saw from the Hawkins and Midgley paper. So that's an interesting finding as well. Nurse and start for the interviewer remain distinct and look like the Australian English model. Okay, and we see some nice examples when she's talking about things like, they're looking at me thinking, what on earth is she saying? Or what on earth is she saying? It gets really peripheral when she's animated, emotionally involved. So that's also a nice thing to be able to see in an animation, in a visualization. Also, trap for this interviewee is lower than it is for the interviewer, and this remains more or less constant. Other vowel categories, of course, may tell a different story. So we think that this type of technique, and we're here dealing with a proof of concept, okay, We think this has potential utility for studies of accommodation, lack of it, in conversational interaction, in all sorts of different frameworks, looking for sociolinguistic real-time phenomena such as variable nurse, looking at accommodating in second language production, lingua franca settings potentially, and simply also for the teaching of phonetics. And we look forward to a chance to work more with this. There are references, that's it. Thank you.
Okay, we have about 7 minutes for questions.
More comment really. When dealing with the jitteriness, well, I hope I haven't misled anyone, but the plots I put together don't display. I originally put together displaying averages for every date of birth, but it's like this constant vibration that made no sense.
Yeah.
So
you have a lowest smooth plot, right?
Yeah, that's what I did. Yeah. Right.
Yeah.
I haven't played around with other options, but.
Yeah, we thought about, and I thought we talked about a couple different ways of doing this, and one of the things that, you know, we maybe shied a little bit away from lowest kind of smoothing is we didn't really want to have any, the next token necessarily influence the previous token and vice versa. So we just did a very crude cumulative averaging thing, but there are a number of ways that you could implement that, of course. Yeah.
Can I ask something? So in thinking about how to do this, I mean, the sorts of issues that really come up are, well, what do we want to be able to see? And that's really an issue here. So there's all this jitter and noise. A lot of it we don't want to see, but some of it's exactly what we're interested in.
Right.
So how do you sort of smooth the stuff away that you're not interested in and not smooth over the stuff you are?
And I think it's helpful just for us to see that too, because we don't often, I mean, when we're plotting vowel plots, we always look at averages and just to be aware of, okay, well, this is actually what's happening over the course of the interview. It is really messy and people jump around all the time. So it's just a nice thing to see, I think, to learn.
And actually, just another comment about that too. So we only showed these 3 vowels mostly because they're the 3 vowel categories. There actually, I think there were 5 vowel categories on the vowels sort of flip-book class. But it's sort of amazingly uninterpretable once you add any more than that. You know, you just can't look at more than a few vowel tokens at once and make any sense of it. And so that's another challenge, is you really sort of have to have some hypotheses that's being.
Yeah, it's a kind of motivated looking.
Yeah, I mean, maybe it's 2 things. You need a running average in some sense, the last 10 of these tokens or something like that. But maybe you should be describing them with ellipses rather than points. I mean, maybe the ellipses are not changing as much effectively because they're somehow, I don't know, just get a feel that the space which is occupied by the vowel might be more stable than its central.
Well, that's certainly the visual impression you get from the vowels plots, where the ellipses are sitting there in the background all the time. And what you're seeing is things moving within those spaces,
It's interesting that you had to do all that alignment. I think it seems an awful lot of work, doesn't it? Do all the alignment and pull out all those formant frequencies. And it's a shame you can't just do that from the audio signal.
From the audio signal,
I mean, you wouldn't have the identity of the vowel, but you'd know where you were in the vowel quadrilateral. There's some way in which you could automatically cluster the vowel qualities and then just see if these vowel qualities are shifting with time or merging or whatever.
In some applications, you could read from a prepared text. Would it work fast enough then? Does the forced aligner work quickly enough for the subject to be tracked through text when the vowel's picked out?
Oh, actually, in real as it's reading?
I'm thinking of a visual feedback device, for instance.
Oh, right.
There's no problem with doing the alignment in real time. The alignment works thousands of times faster than real time. Making it all work synchronously, and it might be a bit of a problem.
I know, I mean, the Google API does let you pull data, so that this is used a lot in financial analytics and things, so you can have charts that are tracking the stock market. So theoretically, that could be done with the tools that are already available if you had the alignment, or the extractor that worked.
Have you thought about taking it from this motion chart that we've got, crunching it back down to condense the dimensionality of it to track these metrics in some other kind of space. So kind of the idea of, you know, you've plotted it, you've got the motion, you've built up this n-dimensional space, and then you can actually use that and use those vectors in that space to crunch back down to get a sense of closeness or movement.
So F1 movements or F2 movements or something, is that what you mean?
You know, you can think about things like, you know, conceptualize acceleration or velocity or that within that space, and that might give you something that's informative about, you know, how they're moving, like the degree of accommodation that's going on between that. Have you thought about that?
Not much.
That's it.
No,
No,
that's a good idea, actually. Yeah, that would be something we could use.
Yeah, I think I've been sort of tracked onto thinking two-dimensionally, because as a sociolinguist you tend to look at these things two-dimensionally. So you're interested in not just F1 movement, F2 movement, but the two together.
Yeah.
So, but you're right that one could pull it apart. Yeah. Okay.
Just one final observation. One thing to make them smoother, of course, is to get rid of formants. So if instead you used the spectral envelope, MFCCs, and then just looked at the first two principal components, see, then you're going to get the same as a formant plot, but it's going to be much smoother because you don't have the errors in the formant estimation. So that would smooth things out a lot as well, I think.
Yeah, I mean, I guess it depends on what the purpose of your analysis is, but that would definitely be a nice way to look
I
at it.
know what you mean by the purpose of your analysis. It's a two-dimensional plot and things
Sure,
moving.
conventionally things are often done in formant frequencies, and for comparability's sake is the only reason I mean that.
At least within sociolinguistics.
Right.
Yeah.
But no, that's a good
Well,
plan.
also, if
No,
you're
that's another argument to be
if
had.
you're specifically worried about changes in the vowel quality, accommodation from one to the other, and I mean, as far as I know, principal components analyses of the spectral envelope don't map onto the same sort of dimensions that we're interested in.
Right.
Like you might not necessarily.
No, at first, two principal components of a spectral envelope for vowels will give you an F1, F2 plot, almost exactly. In fact, it's better than F1, 2. We get better separation between the vowels than you do with just the first two formants. So, and obviously, it's much more related to people's perception as well than formants. So it's actually much better right the way down the line, I think. But anyway, that's an argument to be had.
Yeah, maybe we can continue that argument at dinner. But let's move on to the next speaker. Thank you.